The first two problems really are the keys to section 2.2. So we're on page 16, 2.2, number 1. Write an equation for y varies directly as x. Y varies directly as x. The equation is y equals kx. Now, I'm using k because your book uses k. You can use whatever letter you want. Personally, I like to use m, because when I say y equals mx, I understand what's going on. This is a line, and this number is the slope. But this is the notation your book uses. So if two things vary directly, that's going to be your setup. If they vary inversely, anybody remember what that is? Y equals k over x. That's exactly right. Here we go. Those are the keys to this whole thing right there. So when they say p varies directly as the square of q, that means directly. So I'm looking at this format, but it's not y and x. This is y varies directly as x. This one is p varies directly as q squared. So what would that equation look like? If I'm using p and q squared, it would be p equals kq squared. It's that easy. The next one says m, okay, now go back to this. This says y varies inversely as x. So m varies inversely as the sum of a and b. So what's that equation going to look like? M equals k over a plus b. Easy. Easy, easy, easy. Height varies directly as weight. So h equals kw. Oh, F has a new word in it.
Proportional.
Proportional is another way of saying varies directly. When things are proportional, they vary directly. So we would say y equals kx is proportional to, you can take out and put in varies directly. So when we say rate is inversely proportional, that means varies inversely. So rate varies inversely as distance. So rate equals k over d.
Yes.
Where's the proportional one?
Proportional is the same as varies directly.
Okay.
All right, so now we're going to do a little problem. See how good we really are at this. Temperature is directly proportional to volume. Stop right there. What's that equation look like? Temperature varies directly as volume. Temperature varies directly as volume. So what is that? T equals kV.
Yeah.
So the first sentence, I'm going to write down the relationship. Now, if the temperature is 70, then the volume is 30. See what I did?
Yeah.
I just plugged in the numbers that they gave me into the equation I built in the first sentence. So that tells me K equals 7/3, 70 over 30. So now if I go back to my beginning equation, now I know K or T equals 7/3 times V. Right? Find the temperature if the volume is 20. Find the temperature if the volume is 20. Is that possible?
Yeah.
That's easy. Right? So that would be, what, 140 over 3? So the temperature is 140 over 3, or whatever decimal that is, or mixed number that is, however you want to write it. So let's look at that problem again. The first sentence gave me my general formula, right?
Yes.
The second sentence gave me some numbers to plug in so that I could figure out my K. And then the third sentence actually asked the question. It said, okay, I'm going to give you one of these, T or V, and then you're going to figure out the other one. B. Volume varies inversely as pressure. Volume varies inversely as pressure. So what is my equation, my standard general formula going to be? Volume varies inversely as pressure.
Yes. So you get 200 equals K over 40.
Then if the volume is 200, the pressure is 40.
Yes.
So I can solve for K.
Yes.
It's going to be 8000.
Yep.
So now I have an equation that instead of looking like this, it now looks like this, because I know what K is. Find the pressure if the volume is 950. See what I'm doing? Now I need to solve that. Let's not get wild and wacky. Let's multiply both sides by P. So 950P equals 8,000.
Yep.
And then divide by 950. So P is whatever 8,000 divided by 950 is. I heard a calculator come out. What? 8.42. When you look at those word problems, kids, they seem overwhelming, but try to do one sentence at a time, and I think you'll be okay. Remember, if things vary directly, it's y equals k times x. If it's inversely, it's y equals k divided by x. That's really the big thing. Okay? Now we're going to do the fun stuff. Here we go. We are going to sketch some polynomial functions. Now, you're looking at this and thinking, wait a minute, she wants me to draw this without my calculator? The answer is yes. And it's easy.
You just make y equals 0, right?
You know a couple of things already before we even get started, and I need you to really, really think about this. If you were to FOIL all that out, which we are not going to, but if we were, it would be, what would be the power? X to the third. And you have a BFF that is your x cubed, your cubing function, and you know it looks like this. What you're going to graph is going to be a variation of that. But what I need you to remember about this is, if you are a cube function, you start down and end up. So if you are a cube, you're going to start down and end up every time. Now that's important. You need to remember that. So, first thing I'm going to do is plot my x-intercepts. They're called the zeros. And the zeros are going to be, like you said, Jalen, they're going to be at -1, +2, and +3. Those are the x-intercepts, or the zeros, and they come straight from the factors. Now I'm going to connect those dots with a squiggly line, and I'm going to remember that it's a cube, and because it's a cube, it has to start down here. So it starts down here, and it comes up to this point, and then it connects to this one, and then it connects to this one, and then it ends going up. I am done. That's all there is to it.
Okay.
Now, what we don't know is how high this goes. I don't want you to worry about that. That's a calculus problem. We can do it with our calculator, but we're not ready to do that by hand yet. So just have it go up. And likewise, I don't know how far down this goes. It's okay, just have it come down and go back up. I'm not worried about those heights and depths at this point. That's it, we're done. Let's look at B. All right, so let's see, we've got x plus 4, x minus 2, x plus 3. Is this another cube? So we're going to go ahead and plot our x-intercepts, or our zeros. So we'll put one at -4, and one at 2, and one at -3. Now I need to connect all those dots with a squiggly line. And because it's a cube, I know it starts down, so it starts down here. Here we go. Who needs a graphing calculator? Not us. Now, let's look at the next one. There's something a little bit different about the next one. What's different about it?
There's an x squared.
Okay. There's an x squared. Now, is this still a third degree polynomial?
Yes.
So it is still going to start down and end up. This time, though, we only have 2 x-intercepts, 2 zeros, because that one is what we call a double root. It counts twice. Now, what does that mean in terms of the graph? If you have a double zero, a double root, a squared factor, somebody said, they called it a squared, and I know from my BFFs that squaring results in what shape? A parabola. So this is what we call a bounce-off zero. In other words, we still start down, but when we get to that point, because it's a squared zero, it bounces off. It doesn't cross through. It bounces off. It makes like a little parabola there. Then it comes down and connects to this one. Now, is it going to bounce off that one?
No.
No, it's not squared, so it's going to pass right through that one. And isn't that what we would expect? Start down and up. If you have a squared zero, it creates a little parabola at that point. It's a tangent, we'll call it tangent zero. It bounces off. It's just tangent there. This is called a pass-through. That's a pass-through zero. And they're almost always pass-throughs. The only time they're not is when they have powers on them. All right, let's look at the next one. Whoa, whoa, whoa. Now, there's a couple things different about this one. First of all, this is not a cube anymore. Would you agree with me?
Yes.
If I FOILed this out, it would be x to the 4th. Now, we don't have a BFF that's x to the 4th. But luckily, all even powers behave the same way. So when I say that, what do I mean? How do squares behave? They start up and end up. That's how squares behave. Any even power behaves that way. So if you have an x to the 4th, an x to the 6th, an x to the 8th, it's going to start up and end up. As opposed to an odd power like x cubed that starts down and ends up. Okay? So I don't know what this looks like, but I know that it has a 0 at 2, and it has a 0 at -3. It's a 4th degree, which means it starts up. It starts up. That 0 came from this factor, which is squared. So it's going to bounce off there. And it's going to come down and get to this 0. You have to connect these dots. But what happens when it gets here? It bounces because that one is squared also. So what do we have? Start up, end up. Just like it's supposed to.
Didn't we do something? No.
Huh?
That just reminds me of the last test we took with the everything
Well, we box
right
problem.
side and then move it over. I remember.
Yeah, the box
Reminds
problem
me
is a
of it.
polynomial, so we were looking at a piece of that for sure. Okay, oh my gosh, look at E. So we have x plus 1 squared, x minus 2 squared, and x plus 5. All right, so let's not panic because it's big. We are going to sketch this. So we'll have a 0 at -1, and a +2, and at -5. Everybody still with me here? Big problem, big problem. If we gotta connect these dots now, but we have to know where to start. If we FOILed all this out, what would be the degree? What would be the biggest power on x? 5? That's odd. What do we know about odds? Start down and up. So we're gonna start down here. Now, when we get to this point, we have two choices. We're either going to pass through it or we're going to bounce off of it. Well, let's see. That one came from here, right? There's no power, so it's just going to pass right through. At some point, it has to turn around and come down to this guy, right? Now, what happens when it hits that one, which came from this one? It bounces off. At some point, it has to come back down and hit that one. It bounces off. And then I'm going to stand back and say, that's a really funky looking shape, but does it behave the way a fifth should?
Yes.
It starts down and ends up. Oh Lord, just when you thought it couldn't get any more, look at this one. What's different about this one? It's a cube. So we got a 0 at 3 and a 0 at -1. If we were going to multiply all that out, what power would it be? X to the 4th, that's even. Evens start up, end up. So I'm going to come in from the top. And what am I going to do when I hit that point? Pass right through it. Now, here's where things get a little bit funky. When you have a cubic 0, it actually behaves exactly the way x cubed does. So in other words, when you have a factor to the third power at that 0, you're going to have that squiggle just like you do with a cube. So it's not a pass-through. It's not a straight pass-through. It actually is a squiggle-through.
Okay.
I know. So now we have 3 behaviors, x-intercept behaviors to talk about. If it's a regular factor, just a plain old regular factor, you just shoot straight through it. If it's a square, you bounce off of it. And if it's a cube, you squiggle through it. Now here's the good news. If it's anything bigger than that, it repeats those behaviors. So if you had one that was to the 4th, it would bounce off. If you had one to the 5th, it would squiggle through. All even numbers, it bounces off. Any odd number, it squiggles except 1. If it's 1, it's just straight through. There's a lot to know, but it's easy, luckily. All right, let's take a look at G. All right. Okay, here we are at G. All right, so I can see that I have zeros at -1. 3 and at -2. Now, kids, I don't want anybody thinking that -2 has anything to do with an x-intercept. X-intercepts come from the factors. You know a number out in front is a vertical stretch. It multiplies the height. We're freehanding this, so I'm not even worried about that 2, but I'm worried about the fact that it's negative. What is that negative going to do to my picture? It's going to turn it upside down, which means if it normally starts down and ends up, it's going to start up and end down. If it normally is start up, end up, it's going to be start down, end down. So I got to figure out what it is. Multiply it all out. What power do we have? X to the 4th. It should be start up, end up. But because of the negative, it's going to start down. When it gets to the x-intercept, you have 3 choices now. You're going to pass right through, you're going to bounce off, or you're going to squiggle. That came from this, right? Pay attention to where it came from. That means I'm just going to pass through. Now, it has to connect to the next stop. So it passes through and then comes down. Now, what does it do when it hits that one?
Passes through.
That one came from here. It passes through.
That's all.
When it gets to that one, because of the squared, it's going to bounce off. And sure enough, we start down and end down, because we're a negative x to the 4th. Oh my goodness gracious. Look at this. Oh boy. Now, guys, seriously, when you go home tonight, you're sitting around the dinner table and your parents say, "What did you learn in school today? Whip out your napkin and write this down for them." They'll be impressed. That is quite a problem. And you're going to do it without a calculator. You're going to sketch this. So first off, let's get our zeros on here. -2, 1, and 3. By the way, you notice every problem Mrs. Ford's done, she's labeled her x-intercepts, right? I'm going to get in that habit. We're going to label them.
So we should label.
Yes. Now, I know these dots have to be connected. They're going to be connected either with pass through, bounce off, or squiggles. But I need to know where to start. So I'm going to look at the degree. I've got 3, 4, 5, 6. This is a 6th degree.
Yep.
6th degree should start up, end up, but there's a negative in front of it, so it's going to start down. Now I'm looking ahead a little bit because this 0 came from here. That's a 3, so I'm going to have to squiggle through.
Yep.
So squiggles, you have to consciously squiggle. That is like your cubic function, right? Just draw your cubing function right through that point. And then at some point, you're going to come up and turn around and get to this one. What happens there? Straight through. No squiggling, just straight through. What happens when you get to the 3? Bounce off. And there we go. Now, if you were to graph this on your calculator, it wouldn't look exactly like that. Because, do I know how high up this went? No. Do I know how far down this went? No. So your calculator will graph it more exactly. We're just doing a general sketch, you know, for the general shape of it. Okay, think you got it?
Mm-hmm.
All right, next section then is the same thing but backwards. In other words, I've drawn the picture and you're going to write me the equation. So if you look at your picture,
Yeah, I have a question about that.
Hello.
what?
0, 2.
Why do I feel like I'm left out of a conversation here? What's going on?
Well, at first I said like hello because I thought like I totally missed something on that problem, but then I flipped the page over and now I get it.
Okay.
Well, I don't get it yet, but I
All right.
understand where.
So here's the picture. The picture's been drawn, and we're now going to write the equation. So let's think backwards. We know our equation is going to be 3 parentheses. How do I know there are going to be 3 parentheses? Because there are 3 X-intercepts. And remember, the factors give you the X-intercepts, right? So what's going to be in those parentheses? X plus 2 minus 1 minus 3. Now I heard somebody say this one's squared. How do we know that one is squared?
Bounces.
Because it bounces. And whenever you have a bounce off, you're at least squared. We're going to go with squared. It technically could be to the 4th or 6th or 8th, but we're going to go with squared.
What about that 0, 2 up there?
What about that?
Negative 2 throwing me off.
That's a
Well,
Y
Marina has noticed something. She has noticed that this is a 4th degree equation. There are 4 x's in here. X to the 4th. If you tell me I have an x to the 4th, I'm supposed to start up and end up. This one is,
There's a negative.
so there's got to be a negative out in front. Plus, because I've given you this random point, we have a vertical component to the picture. I'm going to call this number n. That number is missing. Remember in this problem it was a negative 1/3, and another problem it was a 2 or whatever. I don't know what that number is. That number can't come from the zeros. All the zeros can do is give me this part. Any idea how I'm going to use that point to help me figure out what that number is? Exactly. Thank you, Bo Sanders. Plug in y and x. This is a coordinate pair. So if I let y be 2 and x be 0, I should be able to figure out what my n is. I'm going to put 2 in for y and 0 in for all the x's, and I'm going to figure out what my n is. Here we go.
Does n just mean like the number?
Mm-hmm.
There's a
The coefficient. So that's 2, that's 1, that's -3.
-6.
So 2 equals -6n. So n equals -1/3.
Yep.
So my equation is y equals -1/3, x plus 2, x minus 1 squared, x minus 3. Nicely done. This number is what gives the verticalness to the problem. That's your vertical stretch number. You multiply the height. You have to figure out what that number is in order to accommodate that given point there. That point is not an x-intercept. These give you the factors. That is the point that helps you figure out what the n is. All right, let's try B. So, get started. Don't be overwhelmed and frightened. Get started. So we've got a picture that looks like this. So what's the beginning? Y equals, what are my parentheses? X plus 4, x plus 2, x minus 3. Now, anything squared. I'll tell you the biggest mistake that's made here is kids forget to look for the squared. Do we have any bounce offs?
No.
Nope, so we're good, that's it. The only thing I don't know is what this vertical stretch number is out here in the front. So what do? Plug in what? And the y and x I'm going to use are right here. So -3 equals n times 0 plus 4, 0 plus 2, 0 minus 3. What is that? -24. So n equals 1/8. Now, first of all, does it make sense that I got a positive number this time? Does that make sense?
Yes.
Why? It's a cube.
Yeah.
And cubes start down and end up. So yes, I need that number to be positive. And there is the answer to the question. You don't multiply that out, just leave it alone. That's the answer. Are you thinking this is the easiest day in pre-cal ever?
no.
Yes, this is so easy and fun. I feel like we're just accomplishing a ton. All right, try C on your own. See what you can do with C. How many parentheses do you have? 3. Gotta have 3. Got 3 dots. Gotta have 3 parentheses. X
Plus 2.
plus 2.
Squared.
What's this one?
X plus 0 squared?
X, it's gonna be x minus 0 or x plus 0. It doesn't make any difference.
Isn't that squared though?
Well, I don't know, I haven't done that yet. Would everybody agree these are my parentheses?
Yeah.
Now you are right on top of it. You're saying, look, the 2, 1 is gonna be squared, and the 0, 1 is gonna be squared, right?
Yes. So it's an odd number.
The only thing we're missing is this.
Yep.
So we're gonna put in the point 2, 2 this time. So 2. 2 plus 2. 2 minus 0. 2 minus 3. So I'm putting in 2 for the y and 2 for all of my x's.
You said it doesn't matter if we
Arithmetic.
add or subtract the 0, right? Okay.
Yes, does not matter. 2 plus 2 is 4
4.
squared is 16. 2 minus 0 or 2 plus 0 is 2 squared is 4. And that one's not squared, so that's just -1.
Yep.
So 2 equals, timesing it all together, -64 n. So dividing and reducing, n is -1/32.
Yep.
Now, when you write your equation, it is perfectly okay. It makes no difference. It's up to you. I have x plus 2 squared. This one, if you just want to write that as plain old x squared, that's fine. And then x minus 3. Whenever you have the origin involved, that's a plain x. X minus 0, x plus 0, or plain x, however you want to do it. There's your equation. Okay? Andy. Okay, D, do not be alarmed, it's written differently, that's the only difference, there's no picture drawn. It says these are the zeros and it contains that point. Since they didn't tell me any of the zeros were duplicated, I'm assuming that they're all just plain pass-through zeros. So my factors will be x plus 1, x minus 2, x minus 4. Does that make sense to you? If they want a 0 to be a multiple 0, so it's like a squared one, they'll have to tell me that. I can't tell from a list. So I'm assuming since they didn't say anything, these are my factors. Now I gotta figure out that number. Did they give me an extra point? 110. So 10 in for y, 1 in for all of the x's. So 10 equals n times 2, -1, -3. What is that? 6n? 10, 6 is 5/3, is that what you said? All right, everybody's still keeping up okay? Oh shoot, we're almost out of time. Well, we're kind of at a good stopping point anyway, because what's different about this next one? It says sketch.
You have to factor.
You gotta factor it first. That's right, you gotta factor it first. Because in order to sketch it, you have to have it factored, because what do we use the factors for? The factors tell us where the zeros are. That's exactly right. Wonderful work today, people. Keep up the good work. Have a great day. Try to stay awake in all your other classes.